Today we're going to finish lesson 3 notes on exploring angles. We have 2 parts left. We have to take a look at the angle addition postulate and we have to talk about angle bisectors. So starting with the angle addition postulate, this postulate says if point B is on the interior of angle AOC, the interior is everything inside of the angle. Of course, this angle extends forever, not just what's on your paper. Okay, so if point B is on the inside of my gray shaded region, then the measure of angle AOB plus the measure of angle BOC is equal to the total measure of angle AOC. So it just says you can add up the smaller angles to give you the total or the larger angles. Looking at number 1, what is the measure of TSW if the measure of angle RST is 50 and the measure of angle RSW is 125? So RSW is the total angle. That's this whole thing. RSW is 125. Okay, for explaining purposes, I'm going to label the missing angle measure, so TSW highlighted in green. I'm going to identify this as x degrees because we're looking for that. So when I write out my equation, I'm going to fill in my value for x. So I know that my smaller angle, which is the angle highlighted in green, TSW, plus the angle measure of 50, which is RST, is equal to 125. When I write this out as an equation, I have x plus the measure of 50, and I know this is equal to my total angle measure of 125. When I solve for x, I subtract 50 from both sides, giving me x is equal to 75. All right, knowing x is equal to 75, I'm just going to complete my problem by writing it out as an angle measure because that is what the original problem says. So up here we have the measure of TSW. I'm going to write the measure of angle TSW is equal to 75 degrees, and that's my final answer. You wouldn't be wrong to just leave it as the variable x, but I just like to make sure my answer is complete based on the problem that was given to me. And that's everything you need to do for number 1. Number 2, you have to assume a little bit more information about number 2. So we're going back to a couple pages ago in the notes where we talk about a straight angle. So DEF is a straight angle. If DEF is a straight angle, that means it's equal to 180 degrees. So you do have to recognize this, just like you would have to recognize a 90-degree angle. If you see a straight line such as this one, that line measures 180. Now going over what the rest of the problem tells us, we see that DEG is equal to 145. So I can fill that in as DEG equals 145 degrees. We know that the total angle is 180, and we are looking to find the measure of angle GEF. If I write out my angles, I know that the measure of angle DEG plus the measure of angle GEF is equal to the total measure of angle DEF. Now if I fill in my values, I know that DEG is 145 degrees. I know that I'm looking for GEF, so that's the measure of X. And I know that my total straight angle is 180 degrees. So if I subtract 145 from both sides, I see that X is equal to 35 degrees. And once again, knowing that X is 35 degrees is the answer, but the original question asked us for the measure of GEF, so I'm just going to write it out as the measure of GEF using the correct notation. That's equal to 35 degrees, and that's my final answer. So you add up the smaller segments and you set it equal to the larger segment. You solve for whichever segment is missing. Next, we're going to talk about an angle bisector. So an angle bisector is similar to that of a midpoint that we talked about with a line segment, but of course an angle bisector is specific to an angle. So a ray that divides an angle into two congruent angles is called an angle bisector. If we look at this model that I have, we have Y as our vertex, and our angle bisector is this here. I know that that's a bisector because I see that I have a 60-degree angle on this side, and I have a 60-degree angle on this side. Two of the exact same angles indicates that you have an angle bisector. Also, don't forget from last class that these little arcs indicate congruence. So this is telling you that angle XYW is congruent to angle WYZ. And just while we're talking about notation here, if you're using a congruent symbol, you do not use the little m for measure. You only use m for measure if you're writing it as an equal sign. So you could either write this as angle XYW is congruent to angle WYZ, or you could write the measure of angle XYW is equal to the measure of angle WYZ. I know these two things seem very similar, but you do have to make sure you get the notation correct. So if you were talking about just congruence, you would write this. But if you were talking about the actual angle measure, you would write that. Like actual angle measure as in 60 degrees. So a specific angle measure. All right, the first example says, given the diagram, calculate the missing measurements. If the measure of XYZ is equal to 11x plus 10, and the measure of angle 2 is equal to negative 4 plus 7x, find the value of x. A couple things to highlight on my chart over here, or on my diagram. I see from the angle arcs that angle 1 and angle 2 are congruent. So if the measure of angle 2 is equal to negative 4 plus 7x, then this arc indicates that angle 1 is also equal to negative 4 plus 7x. That means YT is a bisector. I should be more specific. Ray YT is an angle bisector. Okay, if it's an angle bisector, that means we can set the angles equal to one another, and we can solve for x. As for solving this one, we see, or we're going to highlight, that the total angle measure of x, y, z, that's the entire angle, is equal to 11x plus 10. So when I write out my function, I'm going to write that the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle xyz. Because again, xyz is the entire angle. Add up the two smaller angles, that gives you the total angle. Also, I'm going to make a note, which you should all make too, that if you have a bisector, you have two of the same angles. So if these two measures or angle measures are equal to the same expression, I'm going to fill in -4 plus 7x for both of them. And we know that this is equal to 11x plus 10. Again, the two smaller angles add up to the larger angle. So now we need to add the left side of our equal sign, and I'm going to add my common terms. So I can add -4 plus -4 and 7x plus 7x. That gives me -8 plus 14x. And this is equal to 11x plus 10. I am going to add 8 to both sides, leaving me with 14x is equal to 11x plus 18. And then I'm going to subtract 11x from both sides, leaving me with 3x is equal to 18. From here, I divide both sides by 3, and that gives me the answer of x is equal to 6. So the directions here specifically tell us to find the value of x. That's what the directions say. So this is going to be my final answer. But suppose the direction says to find the angle of measure 2. If that's the case, then you're going to want to substitute x back into the measure of angle 2 and solve for that missing measure. So I'll do that off to the side just as, kind of an extra part of the notes, but this is not going to be your answer. You do need to make sure you answer based on what the directions ask for. So knowing that the measure of angle 2 is equal to -4 plus 7x, and also knowing that x is now equal to 6, we just solved for that, we have -4 plus 42, which is 7 times 6, and that gives us the measure, or the angle measure of 38. Oops, measure of angle 2 is equal to 38. And you can check your work by, adding up or substituting x back into the original expression that we wrote out and making sure it comes out to be equal. I think it is a good idea to check your work, and there's numerous different ways to do that. Okay, before we end the notes today, I just want to add in one extra thing. So we briefly talked about congruent angles and how we mark them in the last example, or the last set of notes, which was yesterday. So looking at a very basic example and angling or numbering the angles with reference numbers, I'm just going to write in a couple congruent marks, and I just, want to write out the statements just as extra practice. So when you're looking for congruent angles, you're looking for matching angle arcs. So if each angle arc has one single arc, that's going to indicate that the measure of angle 1 and the measure of angle 3 are equal, or you could say angle 1 is congruent to angle 3. Also, if you see two arcs between the angles, you match it up with the other angle with two arcs, and you can indicate that angle 2 and angle 4 are congruent. And this is how you write them. So make sure you have your notation correct, make sure you understand what congruence is,